Here's our little thing for the day. Struggle now. Do the work now. You'll enjoy life later and it'll be nice and easy. Don't do your work now. Enjoy yourself. The struggle will hit you no matter what. So it's now or later. When are you gonna pay? Alrighty. All right. So we already did our locus of control day. Great. I thought there was something else I wanted to announce before this. Now I guess we'll just get into the notes. I hope my pen works. It's been a big pain. You can go ahead and read all this. I don't have the time. All right. Let's just look at this function here and actually talk about instantaneous rate of change, not AROC. Remember, AROC was average rate of change, which was just slope, right? Correct? Everyone with me? Yes, Mr. Samos, there is a class in here, by the way. Right? So average rate of change was slope, and it was a slope between 2 points. And you would have 2 points that you would determine that slope from. That's average rate of change. By the way, I keep adding this. I'm doing a little different than last hour. That is called a secant line. Can everyone say secant line? Secant line. That was fun. Secant. A secant line is a line between a curve that has 2 points. All right, it's nothing special. So what do I have here? This is a tangent line. This is a tangent line. It crosses this curve once and only once, and that's what we're going to focus on today. Some of my notes I printed on Friday or Thursday that we were going to leak into this, but it was too early, and I canceled those parts of the notes. Starting to talk about this. I think this picture is on your notes from Thursday. But this is why this is a tangent line, because that crosses at only that point on that curve. For that point, at that position, there is exactly one and only one tangent line. How many secant lines go through this point? Infinite. That's a secant line. This is a secant line. You get the point. That's a secant line. There's nothing unique about secant lines between 2 points and finding that slope. But as you pull, and this is the concept, I'm glad I wrote this. As you take these 2 points and pull them closer and closer and closer together, then you're getting closer and closer to what the slope of the tangent line is. Can you see that? Right? So as I pull these points closer and closer together, you get close to the slope of a tangent line. I just want you to know that concept, know the idea of it. But just know the difference between a secant and a tangent line is what your job is. So I'm going to erase those right now because they're in the way. And then we're actually going to find the slope of this tangent line. We'll put it right here. And what is it? Hey, just rise over run. I have a point, it seems, that crosses here and maybe here. So 1, 2, 3, 4 over 3. So the slope of that tangent line appears to be somewhere around 4/3. And I did not read this last year. Unless it's a typo. No, it isn't. I didn't. I made a mistake of my students last year. Draw a tangent line at x equals 4. And again, go ahead, draw it, but then I'm just going to go ahead and do it because of time. So I feel like we're going to run out. So the best way I could possibly draw that, already a bad start. Try to draw a line where it skips and doesn't cross it ever again. It's hard to do. I don't think I did the greatest job there. I'd like to kind of turn it a little bit, but I'm going to be good with it. And then it's an estimate, but it looks like I kind of crossed this point and I kind of maybe crossed that point. Maybe I'm a little close. I probably should have. I think I wanted to go in that manner anyway. So 1, 2, 3, 4, 5, and then over 2. It looks like it's approximately, and then let's actually change that to approximately 5/2. And answers will vary on this once you draw the line, but it better at least be positive, and I would think it should be around 3 as a slope for a tangent line there. Now I want you to know that difference between a secant and a tangent line. And I love what I drew before there to tell you that difference. Okay, now you can go ahead and write this down. This was really annoying and took forever. So what they try to do, and I did let her be here. You could not write this or write it. I couldn't care less. But they wanted the slope of the secant line from here to here. which if I were realistically going to go to this graph, here's 0 and here's negative 0.0001. Like really, really close, but negative 0.01. Sorry, I said too many zeros there. But that's not even doing it justice. These are even closer. Negative 0.01 is even closer to 0 than that. And then what I'm trying to do is find the slope of this tangent line, the slope, or secant line. But the concept is these are so close together that this is almost the slope of the tangent line. And that's what I want you to understand. So what did I have to do? What you're going to have to do Friday on the quiz. Input, say it. You have to get the coordinates for 0, comma. Well, it's 0, 0. I mean, look at the equation. When I plug that in, 0 for x, 0, 0, 0, I get 0 as an output value. And then I did the work. I plugged in negative 0.01. I think I showed students on the graphing calculator how you can do this. I don't even have time for that right now. But I plugged in negative 0.01 and just accept that the output was 0.01429. Got it? Okay. And then what did I do between these 2 points? I found the slope. Okay, so you at least have to do that, though. You have to input output, but this is a hard output, pain in the behind. You can do it on your calculator by typing that expression in with the replaced negative 0.01 input. And then I found the slope. And then last year we did this D point and found the slope between 0 and 0.01 on the other side. And then we made a conjecture like it's an average between these two slopes. What the slope of the tangent line was, I guess. Okay. And I think that's what we ended up doing there. All right. So just leave it alone. Here's the concept, what I drew from before. Secant line, secant line, secant line. As I draw these points closer and closer together, the slope of this line is almost becoming the slope of that line. That's how you turn a secant line into a tangent line. You draw the points till they're on top of each other. Okay? Not draw like an artist. Draw like move them closer and closer together. Okay, and now it's time for average rate of change. All right, and this is a big concept that I'm going to try to help you on a sentence you're going to be responsible for on Friday. So today is Monday. I thought I said I was going to go to the calendar. I didn't. I know. I'm sorry. I have ADD. I bounce around. All right, but we have that quiz Friday. Today, I'm going to, try to get everything you need to know for Friday. And then on Thursday, we're going to piggyback off of today's terminology. I have a great thing I made to make you understand what I'm talking about today. But then these 2 days, the 26th and 27th, are reviewing quadratics. All right, because I feel like we need to know how to graph a quadratic in the 3 different forms. And then Fridays are going to be a quiz on all that. Got it? Just so you know where we're headed here. All right. Doink. Okay, now let's just go to this and make you understand something. This is just increasing, decreasing. But I do want you to understand that at this point right here, this is the slope of the tangent line. And that slope is positive, and that's what that means. So the rate of change is positive there. But wait, it's going to get crazy. At the top of this hill, what is the slope of this line? 0. Remember the skier? Skier goes no direction here. What's a vertical line, by the way? What's the slope? Undefined. Why? What happens to the skier when it hits the bottom of the hill? Splat. Body's undefined. Anyway, no one likes that. All right, and then this slope is negative. All right, so that rate of change, what rate of change is equals slope of tangent line. So maybe we should put that down here. Rate of change, when they're asking this, rate of change, that is equal to slope of tangent line. Slope of tangent line. Let's talk like a cave person. Slope, tangent line. So whenever they use that terminology, okay? Now, when I read this graph, sure, it's increasing, now it's decreasing, then it's increasing, then it's decreasing. So it's kind of coincides with that, but now here's where the change is going to occur. Okay, and now you can go ahead and fill this in because we just said that. If the graph of a function f has a positive rate of change, then the graph is increasing. And this is the definition of increasing, because the dependent variable increases as the independent variable increases. We usually do read left to right on a graph, so usually the independent variable is always increasing because we read left to right. So we got to make sure we make that distinction. Decreasing because the dependent decreases as the independent increases. And then we just put silly little things here. I don't know why that picture is still there. There we go. A picture of the calendar there. Child's age as the child's and the child's height. Well, we assume as a child ages, the height increases. The height is the dependent. The height depends upon the child's age. Even though the height of the coin is dropped, the height is decreasing. What happens to the speed of the coin? What does it do? Increases. That's a law of gravity. And it does accelerate at 32 feet per second. Anyone know that? That's in feet. 9.8 meters per second. Anyone know that from physics? That's the gravity on our head rates. Negative. Yeah. So it is expressed as a negative because it is pulling down. Okay, now identify the rate of change for the function. Is it positive or negative? Well, look at A. What kind of slope is that? Positive or negative? 3, 2, 1, go. Positive. Look at B. What kind of slope is this? Positive or negative? But you know what? I want you to do this. I think that is where the point of inflection is. Let's call that the inflection point. There is a change in something else here. And that's what the next concept is. I'm going to hold off on that, but I want to make a note of that. The graph is still increasing at A and at B, but there is a change at B that is after an inflection point. We're going to talk about that next. What's C and D? It's very easy. What's C and D? Negative and negative. So we got positive, positive, negative, negative. Let's be lazy. All right? That's why mathematicians, they are lazy. That's why we make symbols so we don't have to write words. It's true. And I'm not going to feel guilty about it. It is a true statement. All right, now moving on. Okay, so now we got a different thing. Comparing the average rate of change at different point. What happens as I move along the graph? What happens to the rates of change? Now go ahead and get a marker out. Or no, I'm sorry, your highlighters. All I've done is highlight concavity. I've actually highlighted concavity here. What's the blue? What's the concavity of blue? Concave up or down? 3, 2, 1, go. Up. What's the yellows? Concave what? 3, 2, 1, go. Down. That's all they asked me from 0 to 12. And by the way, you're not going to see maybe this picture for a while, but you will see it in February when we're doing graphing of trig, and this is one of our FRQs. The FRQs will have this exact same picture in some of these questions that I'm covering here, but this is a development piece here. I accidentally have one of my tangent lines graph, but here we go. The first part is this yellow part. What's happening from F to G? So comparing the rates of change. And what is the rate of change doing? Is it increasing or decreasing? Not what is F doing. F is the Y's. What are the Y's doing? Well, these Y's are, what are they doing? Increasing or decreasing? What are the Y's doing? They're decreasing. But what are the rates of change doing? Okay, what's the rate of change here? What's the slope of this tangent line right there? 0. And then what's the slope of this tangent line? What kind of number, which is actually listed right there? What kind of number is this? Negative. To go from 0 to a negative, is that going up or down? 3, 2, 1, go. Down. So the rate of change is decreasing. Now here's the difference. Look at the next one, which is part of this blue. I should have colored this better. From G to J, which is from here to here and stop. Okay, this is negative. And then what is this slope down here at 6, negative 7? What is that number for the slope of the tangent line? 0. What does it mean when I go from a negative number to 0? Is that going up or down? Up. So now this graph is decreasing. F is decreasing. The Y value is decreasing. but the rates of change, the slopes of the tangent lines, are increasing. There's the big difference between a graph decreasing and the rates of change decreasing. In this case, they're increasing, they're not. So you got to read and you got to listen and read rates of change, in order to disseminate this. All right, now what's happened from J to K? What kind of slope is that, K, positive or negative? What kind of slope is this, positive or negative? 3, 2, 1, go. And, sorry, wrong. I'm wrong, you're right. So to go from 0 to positive, is that increasing or decreasing? And then how about this last one, from positive to 0, is that increasing or decreasing? So there you go again, another star, another that might be against your brain. The graph itself is increasing. That means the y's are increasing. But the rates of change are decreasing because they're going from a big number to 0. And that's the difference. And then I have another statement to say about this. And that is really the big deal. All right, there you go. If the change in the rate of change is increasing, that's again talking about the slopes of the tangent lines. I'm going to hammer this down one more time. Tangent line slopes. Those are going up. Therefore, that's what we say. Tangent line slopes. Not the y's themselves, the slopes of the tangent line, if you can imagine that. So here's what I did with last hour because I'm worried about Friday. I'm worried about Friday because here's what the rate of changes are doing. I put some numbers. I put, like, say this was m equals -6. It's just steep, so I picked a number. Then I picked m equals -1/2. Not as steep, but still negative. And then this one is m equals 0, right? And then this one might be m equals 1. And then this one might be m equals 6. As I move left to right, what are all of these slopes doing? They're going in what direction? Up, down, or staying the same? What are they doing? They keep going up. From -6 to -1/2 is going up. From -1/2 to 0 is going up. And then it's easy after this. 0 to 1, those slopes are going up. And then 1 to 6, those slopes are going up. So that's this thing. Now it's the sentence. You ready? This is saying then, if I call this F, F is in this moment right here. What's F doing? Is it going up or down? F, the Y values, what are those doing? Going up or down? When I read this left to right, what's my hand doing? Going what? Down. So F is decreasing, because it is decreasing. The Y's are decreasing. Fumble, by the way. And then, but what are the slopes of the tangent line doing? Are they going up or down? They're going up. So here's how you state this. At an increasing rate. Can't spell. Increasing rate. And this is what you're going to be asked on Friday. Thursday, I'm going to practice this. I just want to get it out here right now. Remember, this is talking about the Y's. Sorry. This is talking about the tangent line slopes. Let's make this m of t. That means slope of the tangent line. That's what the increasing rate is talking about. And then what are the Y's doing here? What are the Y's doing? Increasing or decreasing? So F is increasing. And then at an increasing rate. Do you ever do that in notes? That means this copies these words exactly. This is shorthand. We used to teach note-taking in high school. So whenever I do those dashes, that means it just repeats the previous sentence. So the blue part, sorry, this is the yellow part. This is the wrong. This is the blue part. All right, now I'm just going to go over that. So here, F is increasing at an increasing rate. That's because the slopes of the tangent lines are going up. All right, so I'm going to leave that alone, and hopefully you get that. We'll come back to that on Friday. Thursday. Your test and quiz is Friday. Okay, and then I put this together as a synopsis. This is saying the same thing. Hey, what's the concavity of this, by the way? Concave up or concave down? Concave which way? Up. It's not really a bowl because it does flatten out. This is actually an exponential graph. You'll find that out later. But this is concave up. But here is the x-axis. So these f's are above. So the f's are positive. That just means the y's are positive. But what's my hand doing? Going down or up as I read? Down. So f is decreasing. And then what are the rates of change doing? -6, -0.5. Who's bigger, -6 or -0.5? -0.5. So the rates of change are increasing. So this sentence right here separates three different things. Three different unrelated topics. And that's what we really need to do. Star that. That's your new one for the day. Understanding the difference between this and this. They're completely different things. This, if this is the x-axis, then f is negative. F is increasing. And that's concave down. This is -6. That's -0.5. Those are actually going up in value. So the rates of change are increasing on that one. Okay? I'm sorry, decreasing. I'm a maroon. So concave down means this is decreasing. So this is m equals -6. And then this is m equals -0.5. Yeah, I'm actually having a problem with that. So concave down, yeah. So negative, all right? Decreasing because the graph is concave down. All right, now I will tell you this. AP is questions that are somewhat easy, but let's word it as complicated as possible. So that's what we got here. So I'm going to read this in our last few minutes here. The graph of h of t, height over time, I bet is what h of t represents. There's this picture again. You'll see this in a FRQ. And a dashed midline for the 2 cycles is shown. 5 points are given. No scale is indicated. No axes are presented. The t coordinate of f is t1. This is where the wording is all goofy. And the t coordinate of g is t2. So on the interval t1 to t2, all they're saying is what's happening from f to g. That's it. What's happening? Well, number one, you got to look at these coordinates. Whoa, slow down, Sparky. I'm trying to move the screen in class here. You got to know that that's actually the x-axis. Look, -3, 0, 3, 0. This is the x-axis. And if I were to draw it, this would be the y-axis. I'm going to draw it, but then get rid of it because this is y equals 0. So that would be the y-axis if I were going to put this in the coordinate plane. But I don't want that there. That's kind of bothering me. But this one I do because it asks from f to g, from t1 to t2, is h positive or negative? That's what these 4 things. H positive, H is positive, H is negative, H is negative. What is H? Is it positive or negative over this interval? What are the Y's? Are they positive or negative? 3, 2, 1, go. What are the Y's? This is 0, this is 4. What are these Y's? Positive or negative? Positive. So right away, that's the first thing. These are out. That's this sentence right here. What is H? Is it positive or negative? What are the outputs? Are they positive or negative? So that's this sentence. And then it says, is it increasing or decreasing? That's this sentence, not the third one. So what is the yellow doing? Increasing or decreasing? What's the yellow doing? Increasing or decreasing? Decreasing. Just what are the Y's doing? So it is letter B. Okay, now they ask, describe how the rate of change is changing. That's the slopes of the tangent lines. What are the slopes of the tangent lines doing from here to here? Are they going up or down? This is 0 and this is negative. So what does that mean the slopes are doing? They're going down, so they are decreasing. So that is a different thing. The slopes of the tangent lines are decreasing, so the rates of change are decreasing, not the y's, the rates of change, which are the slopes of the tangent lines. Okay, so I really tried to make a big difference between this concept and this concept. And that's really the key of the day. All right, and that's it. We'll close on that one, and I think the buzzer is about to go off. All right, oh, I don't know. I don't know how to stop the video. Where's the thing? Did I stop this already? Oh no. Where's that box? Where's that box with the Oh, there it is. Okay, good. I'm glad that's in the video.